algorithm to find minimum number from given set of numbers. Step 1, start. Step 2, initialize the variables array of size 20, comma n, comma I for iterations, comma minimum. So first we need to initialize, or we can also say we declare the variables. Step 3 is to read the n value. Read the n value. Step 4, read the elements in the array till the size of the array less than n, which means we are going to take the iterator I and we are going to check with the condition I less than n. That is, in total we are reading n minus 1 elements in the array, because the array index starts from 0 to n minus 1. Totally we are going to read the elements. Step 5, initially we need to allocate the minimum value as array of 0. So this we are allocating in order to reference this particular element with all the elements present in the array. Step 6, repeat the loop till I is less than n and check the condition if array of I is less than minimum. If array of I is less than minimum, if the condition is true, then update the minimum with array of I. Whatever the element which is stored in array of ith index, store that value in minimum. So we need to repeat this process till I is less than or less than n. We need to repeat this process till I is less than n. Step 7, print the minimum value. Step 8, stop. So this is an algorithm to find the minimum number from the given set of numbers. The next algorithm, to find maximum number from the given set of numbers. As we know the steps, the first step is start. The second step is initialize or declare the variables array of some size 20, comma n, comma I and maximum. Here in subscript 20 we can give any size. It depends upon the requirement. Step 3, read the value of n. That is, it gives the total number of elements in the array. Step 4, read the elements in the array till the size of the array less than n. Step 5, initially allocate maximum equal to array of 0th element. In array of 0th element, whatever the element we have read, that we are going to store it in the maximum, because in order to refer for remaining elements which are there in the array. Step 6, repeat the loop till I is less than n and check the condition if max is greater than array of I. If it is greater than, then update the maximum with array of I. Step 7, print the maximum value. Step 8, stop. So this is an algorithm to find a maximum number from the given set of numbers. Write an algorithm to check whether a number entered by user is prime or not. What do you mean by prime number? A number which is divisible by 1 and itself is called as a prime number. Now let us see the algorithm steps for prime number. Step 1, start. Step 2, declare the variables n, comma I, comma flag. So here flag is nothing but it is like counter to count the exact value which is divisible by that particular number. Step 3, initialize the variables flag equal to 1 and I equal to 2. Step 4, read n from the user. So I am reading the number, that is I am storing it in n from the user. Step 5. Repeat the steps until I is less than n by 2. So in this given step, there are two sub-steps which we need to process. If the remainder of the number, that is n mod I, is equal to 0, then we are setting the flag value to 0. And we need to process these steps, like again we need to go back to the step 6. And we need to say given number is not a prime number. If this condition is been failed, then we need to increment the given I value by 1. And step 6 is to check if the given flag is 0, display n is not a prime. Else, display n is a prime number. The last step is stop. So this is an algorithm to check whether a given number is prime number or not. Write an algorithm to find Fibonacci series till terms less than or equal to 1000. So we know the Fibonacci series. The first term is 0, second term is 1. The addition of first term plus second term gives the third term, which is 1. Next, we need to swap again the second term as first term and the third term, whatever the resultant we got, as the second term. So this is an iterative process till the n value we are reading. Now let us take the algorithm steps. The first step is start. The step 2 is declare the variables first term, second term and a temporary variable. Step 3 is initialize the variable first term as 0 and second term to 1. Because in the series, the first term is 0 and the second term is 1. Step 4. Display the first term and second term. Step 5. Repeat the steps until second term is less than or equal to 1000. There is a limitation. Till 1000 we need to print those Fibonacci series. And within this step 5, we are having some of the sub-steps. So what is the sub-step? We need to change the temporary, we need to swap the positions of the second term as first term and the given resultant whatever we got as the first term. So we need to swap them. In order to swap, the logic is temp equal to second term and second term equal to second term plus first term. That is our third term. Next, the third step is first term, we need to allocate the value within the first term, whatever the temp value we have stored of second term. And then we need to display the second term. Last step, step 6 is stop. So this is an algorithm to find the Fibonacci series till the term less than or equal to 1000.